Good morning, good afternoon, and good evening. This is the Oracle of Chinenkutu, and welcome back. In this presentation, we have got a question which was part of the preparatory examination at grade 12. It was in paper 1 of September 2019. I have taken part of question 1 and part of question 2. We will do them separately, although here they are shown on the board together. So the first part, which covers the part of question 1.2, is the one that we are going to consider here. And it is saying, given that f of x is equal to 2x squared plus x minus 6, what is we are going to name it, according to our convention, is that the application of inequalities 1, quadratic equations. And as you can see, f of x is equal to 2x squared plus x minus 6 is a quadratic equation. A quadratic equation is any equation of the form y is equal to x squared plus bx plus c, where a is not equal to 0. So in other words, a quadratic equation should have its highest power being equal to 2. So this question has got two sub-questions. The first sub-question 1.2.1 says, solve for x if f of x is greater than 6. So we can say 1.2.1, we need to solve for x given the condition that f of x is greater than or equal to 0. That is the reason why I said inequalities 1, because this condition makes the question an inequality. So we are being told that f of x is greater than or equal to 0. In other words, the expression of f of x itself is also greater than or equal to 0. So we can say 2x squared plus x minus 6 is greater than or equal to 0. Instead of solving this as a normal quadratic equation, which will do, say 2x squared plus x minus 6 is equal to 0, so then we would need to factorize and get the values of x. In this case, we solve it as an inequality. In other words, we can say 2x squared plus x is greater than or equal to 6. If you add 6 on both sides, this goes 6 minus 6 is 0, and this 0 plus 6 is equal to 6. So from there, we can then say factorize the left hand side, which will give us, take out x, and we will have 2x plus 1 is greater than or equal to 0. So now we are going to look at the conditions for which this inequality holds. So if we start by looking at the positive values of x, if we say x is equal to 1.5, this would give us 3 plus 1, that would be 4, or not equal to 0 here, it's greater than or equal to 6. We have already moved 6 from the left hand side to the right hand side. So at this point in time, our inequality is 2x squared plus x is greater than or equal to 6. So after we factorize, it's x bracket 2x plus 1 greater than or equal to 6. So if x is equal to 1.5, this is 2 times 1.5 plus 1. 2 times 1.5 is 3 plus 1 is 4. 4 times 1.5 is equals to 6. So in other words, x is equal to x is equal to 1.5 satisfies the condition of the inequality. Because if we multiply out, substitute for the value of x is equal to 1.5, we will get 6, which is equal to 6. So what it effectively means is that any value of x that is greater than 1.5 also satisfies this equation. For instance, if you take 2, 2 times 2 would be 4 plus 1, it would be 5. Times 2, it gives you 10, and indeed 10 is greater than 6. Therefore, values of x greater than or equal to 1.5 satisfy the inequality. Then we go and look at the values, negative values of x. So the negative values of x, if we look at, for instance, minus 1, this will be minus 2, plus 1, that gives minus 1, and minus 1 times minus 1 gives us 1, and 1 is not equal to 6, and 1 is not greater than 6. So let us look at x is equal to minus 2. We get minus 2 times 2 is minus 4, plus 1, that gives us minus 3, times minus 2, that gives us 6, and therefore x is equal to minus 2 satisfies the condition that this expression is indeed equal to 6. So in other words, if we take a minus 3, for instance, this will give us minus 6 plus 1, that's minus 5, times minus 3, that gives us 15, and 15 is indeed greater than 6. And so all values that are less than minus 2 up to infinity satisfy the condition of this inequality. So therefore, values of x less than or equal to minus 2 satisfy the inequality. So, graphically, this is what we are saying with this inequality. If we draw a number line of the values of x, and we have a 0 there, if we have a 1 there, and if we have a 1.5 there, and if we have a 2 there, we have a 3 up to positive infinity, and we have got a minus 1 there, a minus 2 there, going in this direction up to a negative infinity. What our inequality is saying, and we can say this is x. What our inequality is saying that if x is greater than or equal to 1.5, we put a red solid circle there. So if x is greater than or equal to 1.5, we satisfy the inequality. And then at minus 2, we are saying that minus 2 also satisfies the inequality. So we put a solid circle there. And then we say anything that is less than minus 2 satisfies the inequality as it is given. So this is our solution to 1.2.1, and indeed, if you substitute all these values as indicated on the number line, you will see that they satisfy the inequality. If you look at the question 1.2.2, it then says determine the sum of all integers satisfying f of x is less than 0. This question is very simple on the basis of that it has already been answered in question 1.2.1. Since we have said 1.2.1, this inequality here is satisfied by this graph, then that means the inequality that says 2x squared plus x minus 6 is less than 0 is satisfied by the number line which does not satisfy the first inequality. So in other words, from the number line, in the 1.2.1, the integers that satisfy the inequality x squared plus x minus 6 is less than 0 are, if you look at the number line there, the integers that satisfy this portion of the number line are minus 1, 0, and 1. Minus 1, 0, and 1. And their sum is minus 1 plus 0 plus 1 equals to 0. So, in other words, we are saying that by answering question 1.2.1, you have already gotten a solution for question 1.2.2. And this is very important to notice in an examination, as it will save you time. Otherwise, if you do not notice that, you are going to work this inequality as we did the first one. And at the end of the day, you will get the reverse result to this, which would be that x is less than 1.5 and x is greater than minus 2. And then because these satisfy the previous, so in the second inequality, they won't satisfy that inequality. And you will then realize that the integers that are between x greater than minus 2 and x less than 1.5 are actually minus 1, 0, and 1, with minus 2 excluded, and 1.5 is also excluded. And even if it were not excluded, it is not an integer, it is a decimal, so that would be left out. And you will still get to the same solution, but it will take you a longer time to get to the final answer. So that question is done. And if there are any questions you wish to discuss about this question, you can send me the correspondence through my WhatsApp platform 081 44111390. Please do like the videos and subscribe and tell your friends, and also share with your friends and discuss. Let us prepare for the Matric examination. This question is a good question for Matric level students and AS level, as well as students that are doing additional maths and further maths at O level. Thank you.